Reframing the journey. Why AI in manufacturing starts with learning, not leaps. Today, the conversation around AI in manufacturing is no longer about if, it's about how. Yet across the industry, one reality keeps surfacing. Manufacturers know AI is coming, but they're unsure where to begin. We've heard this firsthand from industry leaders. Many fear that even engaging in a hypothetical simulation could inadvertently expose proprietary processes. Others are wrestling with advice that pushes massive data infrastructure investments, long before there's any clarity on how AI will drive actual value. But here's the truth. This fear is not irrational. It's a manifestation of a broader knowledge gap. And in manufacturing, that gap gets magnified when the benefits of AI feel abstract, theoretical, or disconnected from day-to-day operations. That's why we built the TAAIB vCPPS platform, not to replace your operations, but to help you learn, simulate, and validate before you commit to full-scale change. Through this lens, even hypothetical models, when built using structured behavior profiles, synthetic data, and digital twin logic, become a safe and transformative starting point. In this extended walkthrough, we'll show you how even simulated scenarios can unlock real organizational insight without ever requiring access to proprietary data.
Hello, in this video I would like to show you a demo for the tire manufacturing example. Here I have a simulation configured. I have two SKUs, and for each of the SKU I have 3 process areas defined. Each one of them consists of one machine which has a sensor and an actuator. Just for the purpose of time saving, I have it already configured here, and within the next tab there's possibility of the further configuration of the simulation. Here we can see that first of all we have to configure the SKU1, so all of the actions that we are performing now are corresponding to the SKU1. We are going to go with the settings that we have already configured here. Then further on we are required to configure the process areas, so the workflow and the capacity of the machines. Just for the purpose of time saving, I have already predefined those values, so they go from the process 1 to process 2 and to process 3 using the work in progress bins. Then within the next tab there's a possibility for configuring the PLC rules depending on the conditions that we define. Here the machine will produce the part, and I already have them defined. Let's go next, and in this screen we can define the behavior profiles for the corresponding actuators and sensors. So as an example, for the mixer motor we can define the behavior. Is it going to be linear, sinusoidal, stepped, or constant? In this case I would like to have it as a linear. Then the same can be defined for all of the sensors, so in this case I would like to have a random behavior with the starting value of 130, and the same can be defined for each of the sensors and actuators. Then within the next tab we can define the advanced machine behavior profiles. So it corresponds to each of the machine. In this case I would like to configure the mean time to failure for the Banbury mixer with the default settings, and the other thing is the energy consumption. I will also go with the default settings, and the same I'm going to define for the other of the machines. Then let's go next, and in the review and edit we can see the data that we have defined. We have currently defined the SKU1 out of two SKUs. So in the next step, we are going to move to the configuration of the SKU2, which gives us a flexibility of using the different workflow or different settings for the sensors. Now I'm being prompted if I want to copy the settings from the SKU1. In my case, yes, as my processes are consistent. The only thing I would like to adjust is the behavior profiles for the sensors. Here I would like to have a different start value. And for the last sensor, I would like to have a different behavior as a constant fixed value. In this case, 200. I'm happy with the advanced machine behavior profiles configuration. I'm going to move further. And then at the very end, we can review the settings for the SKU2. And we can save the configuration. And now the simulation starts. And if we scroll down to the bottom, we can see the advanced machine behavior profiles and also the data for them that we have configured. We can see the energy consumption as well as the mean time to failure. And at the very bottom, we have a summary of the advanced machine behavior profiles that we have configured. That's it for this video. Thank you.
From hesitation to transformation, a new path to AI-driven manufacturing readiness. What you've just seen is more than a simulation. It's a strategic mirror designed to reflect the possibilities of your own operations safely and securely. Through the layering of digital twin logic, built on the ISO Standardized Asset Administration Shell (AAS) framework, then structured with no-code PLC logic, BPs, AMBPs, and AI modeling, the TAAIB vCPPS platform allows manufacturers to engage, explore, gather insights, and learn, without revealing proprietary secrets or disrupting live production. We're not asking organizations to leap into the unknown. We're offering them a safe runway to build internal clarity and capability. The knowledge gap we often encounter, from doubts about synthetic data to confusion around real-time applicability, isn't a failure of intelligence or intent. It's the natural byproduct of a fast-moving AI landscape outpacing internal preparedness. And in that landscape, doing nothing can feel like the safest option. But as competitors evolve and expectations shift, inaction becomes the greatest risk. That's exactly why we built the TAAIB vCPPS platform's Creep, Walk, Run model, to create a space where teams can move from abstract theory to concrete understanding without starting with actual plant data, systems, or upfront certainty. And here's where the value truly compounds. As manufacturers begin to build digital twin representations of their real-world operations, they're not just learning. They're laying the groundwork for something much more powerful: agentic manufacturing control. Based on our patented hybrid AI framework, the platform doesn't stop at describing what happened or predicting what could happen. It actively guides operations toward optimal outcomes by learning from past good days and adjusting live decision pathways to replicate their conditions. This isn't just AI for analysis. It's AI for action. And it's not limited to a single algorithm. It's a layered orchestration engine, combining grasp-based optimization to explore solution pathways. reinforcement learning to adapt dynamically over time, and generative AI models to surface emergent strategies, all without requiring data science expertise or months of model training. Even in simulated environments, this framework allows organizations to test, refine, and agentically steer operations toward what works best, without waiting until they have the perfect dataset or all the answers. Because readiness doesn't begin with a production rollout. It begins with understanding. And from understanding comes confidence. And from confidence, transformation. That's the TAAIB, vCPPS platform's creep, walk, run promise. And it starts with just the first creep.